As you already noticed, variables are measured in different units. Some of them are measured in dollars, some of them are measured in hours, in years, in percentages. And because of that, the coefficient interpretation, so the interpretation of the results, can be very much affected. But this can be avoided by expressing the variables, so both the dependent and independent variables, or the regressant and regressors, as standardized variables. And on this slide, you can see the formula for doing that. So what we do is that for each observation, right, we demean it, so we subtract from each observation the mean value of the sample and divide everything by the sample standard deviation. And we do the same for the independent variables, for the regressors, so we take each individual observation, we demean it, or in other words, we subtract the mean value from each observation and we divide by the sample standard deviation. So as you can see, the variables are no longer measured in their own units, but now they're measured in standard deviations. So, and instead of running the standard regression, we can run the regression on standardized variables, right? So this is where this sign comes from. And as you can see, when we run a regression of standardized variables, we no longer have the intercept. The intercept is equal to 0. And the reason for that is very simple. Intercept, this is the mean value of the dependent variable. So this is the mean value of y, right? So the intercept is always equal to the mean value of y. But when we standardize the dependent variable, its mean is equal to 0. So since the mean value of y is equal to 0, beta 1 is also equal to 0. So what we get here is actually the regression through the origin, the regression without an intercept. And as I told you in the previous video, unless you're really sure that you need to use this model, then use it. If you don't need to, if you think it's better to stay with the conventional model, with the model with an intercept, please use the model with an intercept. So please don't standardize your variables. Okay, and when it comes to the interpretation of beta 2, it's quite simple. So if the regressor x, so if x increases by 1 standard deviation, right? So that's what I told you. Now the variables are measured in standard deviations. So if x increases by 1 standard deviation, the y variable will increase or change by beta 2 standard deviation units. So once again, when x increases by 1 standard deviation, so it's no longer measured in its own units, now it's measured in standard deviations, y will change by beta 2 standard deviation units.